Good afternoon everyone. I am B. Sangeetha from the Department of CSE working in SNS College of Technology. Today myself and my students are here to explain the deadlock concept, that is Banker's algorithm, by using our DT method. So what is deadlock? Deadlock is something, for example, if I have two printers and one processor, I am giving a print at the same time, then the process will be stopped. So it is called deadlock. Now my students will explain about what is deadlock and how the deadlock will be prevented.
So before going to the topic, deadlock is a situation of the process which each waiting for other source to get entered. So example, if A has a source and B also will be waiting for the A to enter the room. So if B has a source, so A and B both need to be waiting at to enter the house. So in this both need some resources to wait at the door, where without both cannot enter the same room without both need a source to enter the room. So if A and B does not have any one of them does not have a source, so both cannot enter the room. So this is a deadlock. So
I am going to explain the why it is called the banker's algorithm. Imagine a person going to the bank and request for a loan. First, the banker checks. First, the banker checks the overall amount. If the amount is lesser than this requested, the condition will satisfy and give the loan. If it is not satisfied, the bank will be corrupted. Likewise, the resource is called the customer, and the process is called the customer, and the resource is called the money. Here the amount that the customer requested will be
Requested by the customer will be act as a deadlock, where if the amount is not satisfied, for comparatively the balance is very low, here the deadlock occurs because there is no amount to be given. So if the amount is correct, it will be processed as a granted. Now my student will explain.
This is Harni from CSE second year. Now I explain about safety state and safety algorithm. Safe state is nothing but existed a sequence of process where all processes can finish without deadlock. And safety algorithm have four main structures: max, available, allocation and need. And safety algorithm says first we initialize work as the allocation, and we need to find the process we using need less than equal to available formula, and we need to allocate resources, so we use work is equal to work plus available formula, and repeat all the steps until all the processes can finish without deadlock. If all processes can finish, the request is safe. If not, the request was denied. Thank you.
So I am here to explain an example about the banker's algorithm. First of all, banker's algorithm is used to prevent from deadlock. Banker algorithm involves resource allocation, maximum and needs. The need always must be less than the need, less than the available resource, and the formula is need less than or equal to available equal to resource.
So the resource will be allocated based on the process that is pending. If the resource is allocated and the data is available, so it will be granting the process. That is the example of banker's algorithm.
Here to explain about the resource request algorithm. So the resource request algorithm is a part of banker's algorithm, which is used to decide whether the permission will be granted or not. If it is in the safe state, the permission will be granted. Unless it does not allow, so it rejects the permission. So first it checks the system files. If the request is less than or equal to its need, and then it again checks the system fail. If the system request is less than or equal to its resources. So if both the conditions are satisfied, the system allows the system to be granted. So to be conclude, the banker's algorithm is used to avoid deadlocks, and it also resources like needs, permissions and resources.
Hereby we are concluding this session. We have seen about the what we have discussed is deadlock and what the deadlock is, how the deadlock is prevented, and what the algorithm is used and why the algorithm is used. So hope you all enjoyed this video. Thank you. Let's see you next video. Thank you.